Hello YouTube and welcome to Inside Electronics, and in today's episode I'm going to talk to you about isolation transformers. Well, more like a code, my own version of it. Now what you're seeing right in front of the table, actually you can see I just ran out of my space and you can actually see my other stuff that are lying around in my workbench, but let's just focus right here. So what you're seeing right here are two transformers. They are not identical in this case, but what I'm trying to do is I'm trying to isolate something from the actual AC mains itself for safety purpose. Now actually isolation transformers are really good because they are actually providing galvanic isolation from the AC main side to whatever things you are powering to. So which is actually really a must have thing for everybody who deals with mains voltage electricity, because it can actually prevent you from getting killed yourself. The actual theory behind the isolation transformer is really simple. It's actually a transformer. It's actually a 1:1 transformer. Now what you're seeing right here are two transformers. So this is not a proper isolation transformer setup, and that's why I said my version of crude isolation transformer. Now in actual cases, let me draw this for you, and here there's going to be like a theory video. So there is not much to do things here. So in the case of a normal transformer, let me focus here first. So in the case of an isolation transformer, what's happening is this: the AC mains is coming in and goes through a coil. This is the AC input, and it goes to the other side through another coil, right, like that, AC output, and there's a core in between. So this is a setup that is usually with the isolation transformers. Now the number of turns on the primary will be equal to the number of turns on the secondary, and that's the reason why if you give 230 volts in the input, you're actually getting 230 volts at the output. Now you may ask why someone needs a transformer like this, because transformers are usually used to step up or step down the voltage, like the one you're seeing here. This thing right here, if I just focus on that, this thing actually is a 230 volt to 12 volt step down transformer, and this thing here is actually 230 volt to 18 volts step down transformer. Now I'll be explaining these in a moment, but before that, now in this case you may wonder why somebody needs a transformer like this. It is because this transformer is really good at isolating stuff. Now let me draw it this way. If I draw an AC mains power supply, let's ignore that for now, and if I draw a plug, if I now okay, this is the earth. In this I'm drawing the Indian plug here. So this is the earth, and live and neutral will be these two. So normal cases, the AC mains, this pin will go to the earth like that, and one of this pin will be neutral and the other pin will be the AC mains, the live and neutral. So this is the kind of wiring that normally comes in your home. So in most cases, what is causing problem is that the earth line is actually tied together to the neutral itself. Now in your home, you are actually not seeing it, because at your home what you're doing is actually doing the earth to the proper earth ground itself. But at the transmission side, I'm talking about the transformer that is sitting next to your home. And the transformer side, if I draw it right here, let me draw it here. So when the power is transferred from the transformer, let's say this is a transformer. When the power is being transferred, this is a neutral. Let's say this is the phase to your home, what is happening is that this is actually connected to here, and this one is connected to here, like that. Let's ignore this for a moment. And being this the live, this is a neutral. The neutral is actually earthed at the transformer side. So even though you earth this terminal to the actual earth, the mother nature earth, the neutral is actually earthed at the transmission side itself. So what happens is that if somebody touches the live wire, let's say a person standing like I'm actually drawing it the wrong way around, but anyways, let's say person just was standing there and he somehow got in touch with the live wire. Let's say he was poking around with something and he got touched, and say he got touched with this, and because let's assume also that he was standing barefoot, he was not wearing a shoe, so actually his ground is now acting as an earth terminal. Now he is now touching the live pin and his bare foot is now on the ground, and because the transformer at the transformer side, the neutral is also earthed like that, the current can actually flow through this side, through the live, through his body to the earth, whereby completing the circuit to here, which gives him a really nasty surprise. Now that's something that you need to avoid, because that's how you actually get an electric shock. Now I'm, I'm really bad at drawings, but anyway, I hope you understood the idea. Now let's say when you add an isolation transform, now here I'm drawing the same thing again, with this being the earth, this being the live and neutral. Let's say this is the neutral here for just for simplicity, which is earth from, and this is actually earth, and this is the phase. Let's say neutral, phase, and earth. I'm just interchange the position because for drawing simplicity. And let's say this is how the connect is connected, and this earth indicates the earth pin which I mentioned at the point of transformer. Now when you add an isolation transformer, you're taking the neutral and phase like that, and you're actually making a transformer here like that. I hope you can see that, like that over there. So since this is a 1:1 transformer and you're giving into another 1:1 ratio transformer, you're giving into 130 volt and you're actually getting out 230 volt. Now notice one thing, that here in this side the neutral is grounded. So if somebody touches the live with his barefoot, and as I drawn here, if somebody touched the live wire, the current can actually flow through his body to the ground, to the transformer ground, which completes the circuit and gives him a nasty shock. Now in this case, let's say this is the live and this is the neutral, and let's draw the guy again with his bare foot, and he was standing on the ground still barefoot, and his feet is now grounded. But because even if he touched the live terminal right now, the supply can actually, there is no way the supply to go to the ground, because here the neutral is grounded, so the live can actually go through his body. If I show this here, since the neutral is grounded, this current can actually flow through his body to the neutral. In this case, because the neutral is not grounded, he is not going to get a shock, and that's how isolation transformers help yourself, prevent being killed yourself. So this is what we are trying to replicate here with this crude setup right here. So I think you got the idea. Even though this I'm not that good at drawing, I hope my explanation was enough. And now let me talk about what I did with the circuit itself. So here I have two transformers lying around. This one, if I show you, so you can see there's a 12 volt 3.2 amp transformer whose primary is now, let me focus on here. So as you can see here, I have attached two crocodile clips to the primary side, which is then going to be connected to a plug and to a power supply right here. And because this transformer has two separate terminals, this one is a 500 milliamp hour terminal and this one is the 3.2 ampere terminal, which is also a center tapped one, but I just used a 12 and 0 and ignored the other 12 volt pin right there. And this one is actually an 18 volt transformer, as I mentioned earlier, 18 volt 2 ampere. And in this case, the secondary, the 12 volt terminal of this transformer is now connected to the 18 volt secondary of this transformer. So basically the secondaries are connected together. And the other side, usually the side that connects to a plug socket, the wall output, which is a 230 volt output, which is now the 230 volt output. So if I now plug this transformer to the power strip right here, what's going to happen is that the 230 volt is going to be converted to 12 volts AC, which is actually underpowered because this transformer can handle up to 18 volts, but now I'm underpowering it with only 12 volts. And what happens is that because it is not getting the full 18 volts at the input, it is not going to produce a full 230 volts at the output. There's going to be some difference. Now if you use a proper 12 volt transformer itself, a proper 12 volt transformer just like this one, you are going to get a full 230 volt output. And I actually do have one 12 volt transformer exactly like this one, but I have repurposed it for something else for now, and that's why I'm just for the sake of this video I'm doing it with this transformer. So let me show you. Now let me just make sure that nothing is shorted at this side. So if I now plug in the, I'm going to plug in the transformer and I'm going to turn on the power supply. There's a bulb attached to it right now. Let's turn that off. So this transformer is now receiving the 230 volts, which is now being converted to 12 volts. I can show you that because I can now take this 12 volt and I hope you can see that. That is now converted to 12 volts, and the 12 volt is being applied to this transformer, which is enough to produce a high voltage at this side. Let me show you this. If I keep this thing and see that is a high voltage. Now the reason why I am doing it, because I cannot touch the main side of this transformer in my hand, and I cannot touch my feet on the ground, but I can safely do that with this side. If I touch this side, and right now I cannot show that on the camera, but I'm now having my feet on the ground, but I'm not getting a shock. And similarly this terminal not getting a shock, but I cannot touch both these terminals together because it is now live. And because the transformer is isolated, it never makes this thing, it doesn't mean that this thing is safe to play with. It is really it is not that safe. It can still hurt you. Even though it doesn't kill you, it can still hurt you like crazy, Trust me, I got hit with this while playing around, and it definitely hurts. It hurts definitely. Even though it does not feel like what you get from the AC mains, it definitely feels much more painful, Now I'm just going to turn this off, and let me show you what I did exactly over here. Now I have a pen somewhere here. Okay, So now what I did here exactly is this. I just took two transformers. I just took one, let me show you this way, and a step down transformer, 230 volts in. I'll show you the actual image later. Converted to 12 volts, and I use that 12 volt to drive an 18 volt transformer, which then steps up the voltage to, I don't know, let's measure that anyways. But this is the setup that I'm using right now. I'm using this and two transformers. This transformer is that one. This is a transformer, this one. So this is the setup that I'm using it right now, and this is actually pretty inefficient, because in the normal case, in a proper transformer like this one, you only have to deal with a single transformer itself. But here everything is doubled. The copper loss is doubled, the core losses is doubled, the hysteresis loss, the flux leakage. You have two transformers now to deal with, so you're actually talking twice the amount of losses, I think. So let's actually try to power some electronic items using this setup. Now the reason why I built this thing is because I want to test some electronic items that run using the the capacitive dropper circuits. The capacitive dropper circuits. Oh, I forgot to turn on the switch. Now this is an AC light bulb. This is an AC light bulb here, and okay, it's turned on. I'm going to turn this on. So you can see, if I turn this light off, you can see that it is definitely lighting. The good thing about this isolation transformer is that the safety is the number one thing that you get with an isolation transformer. Now let's see. Of course that is working. I cannot let me just do something. I'm going to make this chassis. Yes, that's good. Now I can hold it in one hand, and I hope you can see that. That is working fine. And I have a hair dryer right here. This is a hair dryer. So I'm going to attach. Let me place the hair dryer here, and I'm going to I hope you can hear the sound that it's making. Now let me turn to full power. Okay, that is the full power mode activated, and as you can hear, this thing can actually run electronic components without actually connecting to the mains grid itself. Now let's measure the voltage, and because now I'm underpowering the transformer, I hope you can see that. Because I'm underpowering this transformer, that as an 18 volt transformer, I'm only powering it with 12 volts, I can expect the voltage will be much lower than 230 volts. But anyways, I'm going to measure the voltage, and it is 180, let's say 180 volts. So if I used a proper 12 volt transformer, I could have easily got the 230 volts. But it works. You just saw a light bulb going on and a hair dryer going on. It works. That's all I need. But what I was talking about, the capacitor dropper. If you have a capacitor dropper circuit, the kind of thing that looks like this one right here, the capacitor dropper circuit, which is a blonde one anyways. If you try to plug a circuit that contains a capacitor dropper to a mains voltage, you're going to see some crazy things happening in the grid. Like, the most often case is that if you have a mosquito bat, if you plug that in, and if the plug is loose, you're going to see the lights going crazy in your home. In a second, your home will act kind of like a haunted house, you know. But when you attach isolation transformer like this to test those kind of capacitor dropper circuits, those will not happen. So that's the reason why I'm using this setup right here. Even though it's not a proper isolation transformer, it works in most of cases. And the one major, I forgot to mention that the one major drawback of this setup right here is the current output. Now you cannot draw a huge amount of current through this thing. Even though this transformer is capable of producing 3.2 ampere of currents, and this transformer can handle 2 amps of current, that does not makes this device either 3 amps or 2 amps. You are going to get 1 amp at the best. Usually the current will be less than 1 amp. In this case, because the voltage is lower, the current will not be 1 amp, but if you use a proper 12 volt transformer, you can get the best is 1 amp. That is because you have to deal with a lot of losses. As I mentioned earlier, a lot of losses is happening in this circuit, and also you are stepping up the voltage. Instead of just having a 1:1 transformer, there is no conversion happening, just 230 going in, 230 going out. In this case, there is actually a conversion going on. 230 volt is converted to 12 volt, which is then stepped up to again 230 volts. So because of all that stepping up action, you are actually boosting the voltage by compromising the current. So you cannot draw a huge amount of current through this thing. That is the only limitation. But for normal loads, this can actually, if this can handle I think I haven't actually tested, but I can pretty sure this can drive a home theater system or simple loads like that. For normal loads, it will be okay, it will be fine, no issues. So yeah, that was it. And also the fun part is that I think I've shown you that the fun part of building a circuit like this is that I can do this all the way. You cannot do that with AC mains, but with setup like this, you can always, oh my goodness, but with a setup like this, you can always do this. So anyways, I hope that this video is useful. If you're an electronics person, you probably don't need to watch this video because you already know about these kind of things. But I just thought that I just need to share this piece of information with you, because if somebody is new to electronics and wants to know something about a DIY kind of isolation transformer thing, then this video may come useful for them. And yeah, basically that's it. So anyways, I think this is the only video that is this long in my channel. Yeah, basically, thanks for watching and see you in another video.